Hi kids, Miss Block here, and today we are going to continue within our Earth's Dimension unit by learning how to draw isolines. You're going to want to make sure that you have your notes handy and something to write with. I strongly recommend a sharpened pencil with a good eraser. You can pause this while you're looking for one. As always, you can pause this video to catch up or rewind this video to review any concepts you might have missed or to receive further clarification. Are we ready? Let's get started. So as we looked at yesterday in class, we learned about isolines. We learned that isolines connect points of equal value together, and they help us to read all different types of maps. We looked at isotherms, which helps us to read temperatures. On a weather map, we also looked at isobars, which helps us with pressure. We also spent some time looking at contour maps, aka topographic maps that help us with elevations. It's not going to be enough, though, to just be able to read these maps and interpret them. We're also going to have to be able to draw isolines on these maps. We're going to be looking at isotherms first and then slowly move into contour, intervals, and topographic. Are we ready? So let's look at the rules that we would follow or the steps. The first step would be determine the contour interval you're going to use. This will often be provided for you or given to you. So sometimes it's a little difficult, so you're going to have to examine the picture. Don't skimp on your diagrams. Spend time dissecting it and analyzing it. So if you look right here at the bottom, in little tiny words, you can see contour interval equals 10 degrees Fahrenheit. So we're going to be going by 10 degrees or tens on this map. Now the lines that we draw should always be multiples of this interval. For example, if the contour interval is 10, your lines would be 530, 540, 550, and etc. We're not going to go in a random interval of, say, 537, 547, 557. It doesn't make sense. So we want to make sure we're with like those nice intervals that look like 10 or multiples of 10. We're going to either start at the highest or lowest number on the map and find the nearest interval number. What is the lowest temperature on this particular map? If you said 33 degrees Fahrenheit, you are correct. That is located right here. What would be the best temperature to use for the first isoline? Since we're trying to make this in a way that it's easier to divide up and see all the values, we don't want to start with 30. We're actually going to start with 40 degrees Fahrenheit. And we're going to put a dot on the map wherever we see that number. So you might want to pause this and find all the 40s right now. You should have found 4 values of 40 on this map, or 4 readings. You might not have enough dots to accurately predict the path of the isoline at this time. We're not going to be able to draw a smooth path to help us figure everything out. So we're going to need to find other locations where our line should snake and go through. So you're going to look at all the numbers around the area and determine where else the number 40 should exist. And we're going to place dots in as many locations as we can find. So you might notice right here, going from 40 to 40 here, where would I draw a line? Because I need to connect these two 40s, but which way should my line snake? So let's look and see where we place dots appropriately right now. We have 42 and 46. Would my line go through these two? No. I'm trying to draw an isoline that will divide values that are less than 40 degrees and values that are greater than 40 degrees. Because every point on that line is going to represent 40 degrees. So I need to have had things that are less than and greater than separated. So I'm not going to draw a dot here. Let's skip it. Let's go to another spot. How about between 38 and 42? Yes, the isoline for 40 would separate 38 and 42 because 38 is less than 40 degrees and 42 is greater than 40 degrees. So I draw a dot right there. Also here that I have 33 and 43. 33 is less than 40 and 43 is greater than 40. So I'm going to draw a dot between those two as well. I'm going to continue doing this till I have enough dots that I feel that I could draw a really smooth line. It's better to draw more dots than less dots. So you might want to pause this right now so you can draw in all these dots. At this time, you should have drawn in all these dots. And you'll notice I have a lot of dots here because it's better to have more than less when you're figuring it out. We don't have so many that looks like a dotted line or one of those lines where it says cut here, but you want to have enough that you know where your isoline should go. Now you're going to connect the dots, and you're always going to use a smooth curved line. Don't grab a ruler, don't use a straight edge. You're not going to get a ruler on the Regents, and I'm not going to give you a ruler when you take a quiz or a test for me to do this. Get comfortable with being uncomfortable. It doesn't have to be perfect, but you should make sure that it's a smooth, curved line. The line itself should not have any loops within it. The line itself should not snake up and then go back. It shouldn't make any hooks or anything. So connect those dots. You might want to pause it right here if you haven't drawn the line already. This is what your line should look like at this point. If the line appears to loop around or make a circle, then connect them in a circle. If not, just continue the lines to the edge of the map. So we want to make sure that we have a clear division. So we have the edge of the field or our map right here. So you're going to draw this to the end and this to the end. You're going to label it with units. You can see we label it as 40 degrees Fahrenheit. And then you're going to determine what the next contour value should be and repeat this process until the map is complete. So if we went with 40 degrees Fahrenheit, our next line should be 50 degrees Fahrenheit. I want you to continue this process right now for the 50 degree Fahrenheit line, the 60 degree Fahrenheit line, the 70 degree Fahrenheit line, and the 80 degree Fahrenheit line. You might want to pause this. It's going to take a while. You should have a map that looks somewhat like this. You want to make sure that each contour line that you've drawn here, each isoline has separated the values. So you can see right here, every point on this 40 degree isoline represents 40 degrees. Every value that is less than 40 is above, every value that is greater than 40 is below. We have our 50 degree Fahrenheit isoline right here, and you'll notice that all the values between these lines are greater than 40 but less than 50. And you're going to have this all divided up. Each line is labeled, each line extends from one end of the map to the other end of the map. Sometimes kids get a little worried over here because they're like, why did you make a circle here, Miss Block? Why didn't you make a line like the 70, the 60, and the 50? Well, if you notice, I need to have a way that I'm able to separate the values greater than 80 from the values that are less than 80 degrees. I can't have a line that extends from here to the end because that would separate two 70s. It wouldn't make sense. So I have the 80 and the 80 here, and then I'm able to just loop it around like this. It's okay to do, but it should make sense and according to the map. If the number 50 was not written anywhere on the map, would you still need to draw the 50 degree isoline? Yes, you would still need to draw the 50 degree isoline because we're going in intervals of 10. So if you had 40 and then you skipped to 60, you didn't go in an interval of 10, you actually went now in an interval of 20, and you didn't stay with the standard that we had set. Let's try some practice questions. I would pause this and answer the next couple questions. There's a couple sets of questions that you're going to go through, and then we will go through them and see how you did. I hope that you finished those questions now. Let's go through and see how you did here. So number 1, what is the most likely temperature represented by isotherm AB? You notice right here, this is isotherm AB. The most likely temperature would be 10 degrees Fahrenheit. Let's go through and see why. So number 1, you'll notice that I have a bunch of different values, 17, 16, 12, 20, 16, and then I have above this line 7, 0, -8, -3, -1. Usually our intervals are going to go in values of, say, 5s, 10s, or 2s, sometimes 3s. They're not going to go with a bizarre value of like 8s or 6s. They're going to go with something 5, 10, 2s, even sometimes hundreds. 10 makes the most sense. And notice right here, all the values that are greater than 10 are below, and all the values that are less than 10 are above. We're then going to draw in the isotherm for 0 degrees Fahrenheit. So I'm going to locate where my 0 is, make a dot there, and then draw in the other dots so I can figure out where my line should snake and curve. Right here, you can see I have a dot at the 0. I have this dot here separating the 7 and the -8. I have my 10 degree isoline here and a -1, so all these dots are representing where my isoline will be drawn in. And right there, you can see that I connected the dots. Sometimes kids ask me, can I just draw the line in without doing the dots? I recommend that you don't do that. Why? Because if you draw the line in and it's a mistake, it's really hard to erase this solid line here. By making the dots, and you notice a mistake, it's easier just to erase a couple of dots than a whole solid line. This is also why you should use pencil, because you can't erase pen. In fact, the Regents feel so strongly about this that it's only one of the few areas that you can use a pencil on the Regents. You have to use a pen on everything, but drawing isolines and profiles. We're going to talk about profiles a little bit later, so don't panic about those at this time. Let's look at this one right here. Draw isotherms with a 5 degrees Celsius interval. So since we don't start at 5 degrees Celsius within our field right here, we're going to start at 10 degrees Celsius. We locate the 10 degrees and we draw in the dots, and then we connect them. Notice that we extend to both ends and I label it. It should be 10 degrees Celsius, not just 10. I'm now going to go to the next value. So we go 10, that would be 15. I locate the 15s, I connect all those. I go to 20, connect it like that, and then I go to 25. And just like that, they're all labeled, they all have this smooth curved line, and they all extend from one end to the other. Let's look at our last example right here. You're going to draw a 60-foot contour line. So we're going to go and find all the 60-foot measurements, and then we would go and draw dots in for the values where that line would snake in. That would go in between 60 and the other values. I have all my dots, and I'm going to connect it. I would also label that with 60 foot. The next question they're asking me is, towards what direction is Elma Creek flowing? So if you recall, we discussed yesterday when we looked at topographic maps that rivers always flow from high to low. So from a high elevation to a low elevation, a river is going to flow. However, it's a little tricky to tell right here where high elevation is and low elevation. We only have this one contour line. So what we can do is we can look and say which way the contour lines are pointing. Remember, contour lines will point upstream, so they point in the direction opposite of the stream flow. So right here, if you look, this contour line is pointing towards the north, or towards this way with the stream. So the stream is going to flow downward this way towards Steeler Bay. So the stream is going to be flowing south. I hope that you found this video useful. As always, you can go back and rewatch this video. If you have any questions, feel free to ask me them in class or in extra help. I'll see you soon. Take care. Bye!